Hi everyone! Today we're going to talk about the CrimeOps of the KashmirBlack Botnet. But first, let me introduce myself. My name is Sarit and I'm a security researcher at Imperva for the last 10 years. I mainly focus in web application security and I develop algorithms to detect and protect against attacks. My colleague Ofir is a security researcher for the last 5 years. His focus is in database and web application security. Before diving into the bits and bytes of our research, I would like to introduce you with the KashmirBlack Botnet. So, it all started on November 2019 and lasts 11 months, which is basically a research period of time. We discovered a botnet that attacks popular CMS platforms such as WordPress, Joomla, Magento, etc. in more than 30 different countries around the world. It performs millions of attacks per day on average, and we calculated that there were hundreds of thousands of bots out there participated in the botnet operation. The bots utilized dozens of known vulnerabilities with different attack types like file upload, remote code execution, and many more. This session is a journey into the botnet core from the attacker point of view. So let's start. Security research investigation can sometimes be like a crime scene investigation, but our crime scene is spread all over the network with nobody in place. So we need to collect the clues and fingerprints to construct a picture of the virtual crime. As part of a study carried out at Imperva, we observed around 9 million attack attempts exploiting PHP unit remote code execution. And we were wondering, why is this CVE so popular among attackers? To understand this hype, we started to analyze attacks from our data lake. We saw different IPs using the same payload over and over again, attacking different customers, which remind us a botnet behavior. So we decided to download the payload and dive in. And we basically started the mapping step. We downloaded the code and performed analysis. We revealed all the entities of the operation, and later I will talk about them in further detail. The next step we took was infiltrate. We saw that the botnet is updating on a regular basis, and we decided to act like a bot and gather these updates for later analysis. And finally, we played a victim. We created a honeypot in order to understand the post-exploitation stage. So let's review all those entities that play a role in this massive operation. When looking at the botnet entities, we can split them into 3 groups: the botnet infrastructure, the botnet third-party services, and the botnet actors. Inside the botnet infrastructure, we have the CNC and repositories A and B. Under the third-party services, we have GitHub, Pastebin, and Dropbox that the attacker used in one hand to camouflage his operation, and on the other hand to make the botnet more flexible. Under the botnet actors, we have the victim and 2 types of bots, pending and spreading, and I will describe the difference between them later in the presentation. The first entity in the botnet infrastructure, which is responsible for the entire operation, is the command control. And here we can see the login screen of the CNC. The KashmirBlack CNC is located in Indonesia and has 3 main roles. It supplies attack instructions to bots, it receives attack reports from bots, and it supplies a malicious script that infects the victim server. Here we can see a snapshot of the infection script. The attacker defines a parameter that represents a cron top task, and the task contains a Python script and scheduled to run every 3 minutes. It includes several imports and uses base64 encoding to obfuscate its malicious payload. We can also see that the output of this task will be sent to dev.null, so no history will be saved. In the next code block, the attacker redefines the victim's cron task to include the malicious Python task that we just saw in the previous section. And as part of this redefinition, the attacker makes sure to remove all mail notifications. Let's move to the repositories. The original repository A, as you can see, is a printer component shopping site. It was hacked by the attacker and was used to store the communication script file to communicate with the CNC. Another type of repository entity in the botnet is repository B, which is a site that was classified as an educational institute and was used by the attacker to store bundles of exploit and payloads. Here is an example of the exploit and payload bundles. The attacker files are located under the CSS path, among other CSS files used by this innocent web server. We can see that the name of the bundle files start with the in-memory prefix, and they are actually zip files hidden with the CSS extension. And here is their modification date. One of the best qualities in this botnet is that the infrastructure is just like Plug&Play. The attacker can expand his target victims by adding new payloads just by uploading them here under the CSS directory. No infrastructure changes are required, and every file represents an exploit that targets a specific vulnerability. Here is a partial list of CVEs the botnet uses as part of its operation. Among them, we can see remote code execution, file upload, remote file include, and many more. And these vulnerabilities are related to different plugins, widgets, and themes. And we can say that the conclusion here is that it's not necessary to use exotic payloads, exploits, in order to expand the botnet. Moving to the cloud-based services. Another type of entity used by this attacker is GitHub. It was used as a version control to store some of his files. And when we checked the repository, we saw P3 web shells and crypto miners. And we can say that by using GitHub, the botnet achieves a layer of flexibility. The attacker can easily update a file in this repository without interfering with the botnet activity. Another entity is Pastebin, which is a website that allows anonymous users to share plain text through public posts that they call pastes. The attacker used this paste as a quick and easy way to access and download backdoors through the infection step in the botnet operation. And later we will show how Dropbox was used in order to upgrade the botnet, hide the operation behind legit cloud services, and also to secure the CNC. Now, let's talk about the two types of bots. First, the spreading bot. This bot constantly communicates with the CNC to receive attack instructions. Those are commands from the CNC telling him who to attack and how. This bot is being used to infect new machines and expand the botnet. A victim that was infected by the spreading bot can become one of two, a spreading bot or a pending bot. Now, let's talk about the pending bot. As I said before, this bot is a victim site that was infected by a spreading bot, the one that appears here, and as a result is under the control of the CNC. It stays in idle mode until the CNC approaches and changes purpose. And this is actually why we named it pending bot. And I will talk about the purpose in a bit. And the difference between these two is that the pending bot does not initiate communication with the CNC. Moving to the KashmirBlack Botnet scope, the infiltrate step. The best way to learn of organization is to be part of it. Same for learning about a botnet operation. We call it the infiltrate step. Once we mapped all the entities of the botnet, we wanted to understand the scope of the botnet, its victims, the attacks, and the evolution. And to answer those questions, we had to take a more active approach to the investigation. We learned the communication protocol between the bot and the CNC, and we mimicked it. We infiltrated the botnet by constant communication with the CNC. We went undercover and impersonated a spreading bot in the botnet, and without actually attacking any targets, we started to collect information about the botnet victims. We can see in the picture an example of attack instruction in JSON format, received from the CNC. The first parameter, the script, contains the commands that will be executed by the spreading bot. First, it will run the curl command to download the exploit and payload bundle that will be used to infect the victim. And here is the name of the file to download. We can see it's located under the CSS directory in repository B, the one I just showed you. The second parameter, the payload, contains a list of victim sites that will be attacked by the spreading bot. And the last parameter is the host name, or the IP that hosts all those victim sites. Moving to the botnet purpose. In order to understand the purpose of those victims as pending bots, we had to become a victim ourselves. So we created a CMS honeypot and attacked it with our spreading bot from the infiltration step. Then we reported back to the CNC of a successful attack, and by that, our honeypot became a pending bot in the KashmirBlack Botnet, waiting for the CNC to approach. We saw 5 types of purposes for the botnet. About the first 2, we already discussed. Those are the pending bot and the spreading bot. So we'll talk about the others. An exciting purpose we observed is the crypto miner that mines Monero coins. As part of the code analysis we did, we got access to the hacker's payment address, and we could see his balance in real time. The next purpose was discovered as a result of our CMS honeypot that was converted into a clickbait bot. When we tried to access the honeypot's login page, we were redirected to one of many clickbait sites. And the last purpose is defacement. Once we saw the defacement signature, we discovered the nickname of the hacker behind the botnet. We also discovered that he is part of the Indonesian hacker crew PhantomGhost. Searching the internet, we found out even more interesting information about the crew, like their Facebook page and even an online shop that sells the PhantomGhost crew t-shirts. Now, after we're familiar with all the entities, Ofir will continue and show the entire operation in live.
Thank you, Sarit, and hi everyone. So, how this botnet works? It all starts when a bot exploits PHP unit remote code execution on a victim server. It causes the victim server to download the infection script from the CNC and execute it. Now, the infected server will approach repository A every 3 minutes to download a fresh communication script. In this stage, we can say that the victim server is part of the KashmirBlack Botnet. The newly infected bot communicates with the CNC to get attack instructions that describe who to attack and which bundle to use. Then the bot downloads the bundle from repository B and additional payloads from GitHub and PasteB. Then the bot attacks the victim, and on successful attack, it will become part of the botnet. As a last step in the process, the bot reports back to the CNC. Now that we are familiar with the operation, we can move on and describe the evolution of the botnet over the research period and the DevOps strategy that enabled it to carry out its crimes. Remember that the botnet had only one repository for A and B? Once the botnet size increased, so did the load on the repositories. In addition, since the repositories were actually legitimate sites, they couldn't be considered as permanent and reliable entities. The attacker had to take action. 3 changes were implemented in the botnet infrastructure to solve this: adding new entity, repository A load balancer, expand repository A into multiple repositories, and expand repository B. There were 3 main reasons behind these changes: to make the botnet more dynamic and scalable, add redundancy, and load balancing. The following diagram shows the old infrastructure against the new one. While in the old infrastructure, every bot will address directly repository A, in the new one, each bot will address the load balancer to get one of many repositories. To integrate this change into the botnet operation, an additional change in the botnet was required. We will discuss this change later on. Now, let's talk about internal changes that were made in order to secure the CNC and the botnet operation. The CNC is the most sensitive and critical component in the entire operation. Securing it is critical. Let me take you back a little bit to the steps where we infiltrated the botnet and played the victim. We created the honeypot. We attacked it with our spreading bot and reported back to the CNC. We believe that the attacker grew suspicious as he performed two internal changes in order to avoid interfering with the CNC. The reporting address was changed and bot IP tracking mechanism was added. First change is related to the reporting address. This change helps with managing bots versions. Bot that report to the new address is a new bot. Second change is within the botnet's communication script. It was updated with a bot tracking mechanism. A simple architecture change adds the bot's IP and country while it communicates with the CNC. It allows the CNC to track and monitor the operation of each bot in the botnet. There are two goals behind this mechanism. The first is to secure the botnet, and the second is to manage bots versions and upgrades. Now, let's see how it comes to work. The changes that we described created a situation where some bots were using the new infrastructure, while others were only aware of the old one. This diagram describes the upgrade process. On the left side, you can see the old infrastructure. When an old bot communicates with the CNC without the IP tracking header, the CNC in return sends back attack instruction that will instruct the bot to download the upgrade script from repository B. Once the bot will execute the script, it will turn into a new bot that is now aware of the new infrastructure. On the right side, the upgraded bot addressed the load balancer to choose one of many repositories. Now, let's talk about migrating the CNC to a cloud-based service. There are fundamental problems in the botnet architecture. Since bots communicating directly with the CNC and the repositories, their IP is exposed and security controls may block them. An interesting infrastructure change has evolved to solve this problem, integrating Dropbox into the operation. Instead of communicating directly with the infrastructure entities, the CNC and the repositories, the bots are now communicating only with Dropbox. Now, Dropbox API is being used to fetch attack instructions and upload reports. This is a big step towards camouflaging the botnet traffic, securing the CNC operation, and most importantly, making it difficult to trace back to the hacker behind the operation. Now, let's discuss some key takeaways. Botnet deployment is similar to application development process. There are some important key features we need to consider in order to create a stable botnet that is here to stay. Those are stability, flexibility, and CI/CD. In order to create a stable botnet, we need to take into consideration load balancing and redundancy, enabling scalability while growing. In other words, stability is the foundation that enables the botnet to exist. But this is not enough. The separation of the exploits from the infrastructure enables maximum flexibility, as the attacker can add new exploits anytime. Together, Those two key features are the basics of the ability to grow and expand. On the other hand, we have the CI/CD branch that enables the version control, that includes version control and deployment cycles. We call it automation. Behind every massive operation, we must have an automatic process to support it. Expansion and growth cannot exist without a solid CI/CD process. Now, let's talk about the insider point of view. As a security company, we have data of hundreds of thousands of customers where we can see attack in the wild. But this is not good enough since our data is biased by our customers. Here are a couple of advantages we got from the insider point of view. So, being inside the botnet operation gave us an advantage in the analysis as we could see the big picture and not just a small portion of the infection. We watched the botnet operation and evolution from the first role. We saw new repositories, exploits and payloads added in real time. By analyzing the code changes, we concluded what motivated the attacker to perform such changes. We had a unique foothold that enabled us to analyze the victims from the attack instructions, extracting country, platform, domains, etc. The inside intelligence led us to the educated assumption that there is kind of an automated mechanism that searches for potential vulnerable targets and initiate them in the queue in the CNC. Analyzing the exploit distribution explain which exploits are in use and the distribution of usage. What is the frequency that they are being used and which are more common than others. All of this information is accessible only from the insider point of view, and it is critical in order to understand the scope of the operation, the motivation and challenges of the attacker. Now, let's sum everything that we talked about. In a botnet development, the attacker wearing multiple hats. The attacker is the developer, the architect, and the DevOps. Usage of third-party services are critical part of the infrastructure in terms of camouflaging the botnet and bypass security controls. And it is not necessary to use exotic exploits in order to expand. So what can we do to prevent infection? First, make sure that you are up to date with the latest security patches and that there are no unused or unsupported plugins installed that might increase your attack surface. In terms of research, first we need to map all the entities. We need to learn the botnet communication protocol, and last, visibility is essential to understand the big picture. You are probably wondering what is the current state of the KashmirBlack Botnet. So, when we decided that our research has come to an end, we collected IPs, host names, hosting services, and every possible piece of information, from bots, repositories, CNC, and entities. We notified the owners of the infected servers and hosting services about the malicious activity, and today, the KashmirBlack Botnet is dead, at least as we know it. We checked our data lake and we couldn't find any traces of new infections. Thank you very much for listening to our talk about the KashmirBlack Botnet. Feel free to contact us if you have any questions. For additional information, you can read the 2 blogs that we wrote. Just search for KashmirBlack Botnet on Imperva's site. Thank you.
Thank you.